Hello, everyone. I'm Tetsuo Kokubu from Mitsubishi Research Institute. I'd like to begin by introducing the Tokyo Digital Twin Project. This project is managed by us, which was commissioned by the Tokyo Metropolitan Government. Today we will give a presentation on this project. First, about this project. Last year, Tokyo was selected as the most attractive big city in the world by the American travel magazine Condé Nast Traveler. At the same time, the city faces a variety of urban challenges. These include a declining birth rate and aging population, changes in the movement of people and goods, the climate change crisis, and the risk of a major earthquake directly beneath the capital. To overcome these challenges, it is essential to adapt to change by fully leveraging digital technologies. In response, Tokyo government launched this project in 2020. We have published the roadmap for the realization of a digital twin in Tokyo, which outlines the Tokyo concepts and key components of both a digital twin and urban digital twin. It also describes the future we envision, the steps needed to achieve it, and short-term policy directions. By 2030, Tokyo aims to apply digital twin technology in a wide range of fields, including disaster prevention, urban development, mobility, the environment, and industry. To support this goal, the roadmap defines Tokyo's vision for 2030 as a flexible system in which urban infrastructure data, such as 3D city models and interfaces, are developed and continuously updated, allowing urban data in each field to be used for decision-making by Tokyo government, businesses, and residents, as well as for effective policy planning. We are now in phase 2 of initiative, which begins in 2023. During this phase, we are expanding the platform's functions and developing new use cases. About the digital twin platform, to promote the use of digital twin technology in the daily operations of Tokyo government, we have developed and are now operating the digital twin platform. This platform aggregates geospatial data from both inside and outside the government and allows data to be shared and visualized across departments. The platform consists of an internal data store that collects and stores data from multiple sources, and a data catalog and interface for accessing and using that data, and the viewer to visualize it. And there are two types of viewers, the internal one and external one. The external one is open to the public and available for anyone to use. This platform is developed using Terrier.js, an open source framework widely used in digital twin projects worldwide. And Terrier.js is a Sejum-based open source JavaScript library for 3D data visualization and cataloging. For the 3D globe viewer, the platform uses Sejum.js, an open source library. Terrier.js manages Sejum's rendering features through its user interface. handles data format conversions, and controls the data catalog functions. Terrain data, which forms the foundational layer for visualizing and overlaying 3D data, is delivered via Cesium's on-premises terrain distribution service. This data is also set as the default base layer in the internal viewer. We developed the internal data catalog and internal viewer to enable Tokyo government staff to share non-public data in their daily work and release them in 2023. This data catalog allows users to search, view, and download data, while this viewer enables visualization of that data on the map. And going forward, we aim to expand usage by increasing both the volume of available data and the number of users. Our goal is to promote the platform's use across a wide range of fields, contributing to solving urban challenges and creating new value. The external viewer is an open access geospatial platform that allows anyone to overlay and visualize a wide variety of data directly on an interactive map. As of June 2025, the platform offers over 1,000 datasets, and we plan to continue expanding this number. We are working toward a future where this platform plays a key role in understanding urban dynamics, supporting policy development, and driving innovation in the private sector. This viewer can be accessed via the official website of this project. We encourage you to scan this QR code and explore the platform for yourself. The website is available in both Japanese and English, making it accessible to users around the world. The website also provides a wealth of information, including reports on key challenges and findings from pilot projects, and a manual for acquiring and utilizing point cloud data. These resources offer valuable insights into how Tokyo is advancing its digital twin initiative and working toward full-scale social implementation. Between April 1st, 2024 and March 31st, 2025, there are about 20,000 accesses from overseas users, accounting for approximately 30% of total users. This demonstrates their growing international interest in the platform and its potential for global applications. We are also committed to continuously enhancing the content of the viewer. New datasets are added and the existing ones updated approximately once a month. On the website, users can easily check with which datasets have been updated in the past month. Posted data and development functions. This viewer currently hosts a wide variety of data. Major data types include 3D digital maps, such as building models, transportation models, urban development models, as well as point cloud data, real-time information, disaster-related data, and facility data. The image on the left side left shows a set of 3D digital map layers overlaid on the Shinjuku area, where the Tokyo government headquarters is located. On the right, it presents point cloud data of the same Shinjuku area, providing a highly detailed three-dimensional representation of the urban environment. By layering different types of data, users can gain a more in-depth and multidimensional view of the city's structure and conditions. Other data, real-time data includes river monitoring cameras and port cameras on remote islands, allowing users to instantly check for flooding risks and coastal conditions. And disaster-related information includes various types of hazard maps and data on evacuation facilities. These data sets support risk assessments and the planning of evacuation strategies. Transportation-related data covers real-time train location and bus movement, providing a solid foundation for understanding mobility patterns within the city. The view also offers information on various public facilities and urban infrastructures, including hospitals, police stations, fire stations, and parks, and so on. We will now present a video that overlays the 3D digital map on the Shinjuku area with various disaster-related data on a single map. In this video, you will see the three-dimensional structure of buildings and roads alongside key disaster preparedness information, such as seismic hazard assessments, designated evacuation shelters, and emergency water supply station. This is hazard map. This integrated visualization helps to better understand urban risk areas and supports disaster preparedness planning and decision-making aimed at enhancing community resilience. This viewer is equipped with a variety of features available to users. In addition to the standard functions provided by Teria.js, we have developed and implemented custom features such as area measurement and attribute information search to meet specific user needs. The area measurement tool allows for accurate calculation of horizontal projected areas without taking terrain elevation or slope into account. This is headquarters of Tokyo government. Now let us show you a video demonstration of how this area measurement tool is used in practice. The attribute information search feature allows users to filter and search spatial data based on specific attribute values. For example, when working with building data, users can search by building name, category, or address, enabling quick and efficient identification of specific facilities. This function is particularly useful for navigating and extracting relevant information from large geospatial datasets. Finally, future outlook and initiatives. To promote the use of point cloud data, Tokyo government has conducted practical training sessions for its staff to learn how to effectively utilize such data. These sessions provided hands-on experience with collecting 3D spatial data using smartphones equipped with LiDAR and GPS capabilities. The training aims to enhance practical field skills and to build foundational knowledge for the future use of digital twins. Going forward, we plan to participate in GIS-related exhibitions, not only to promote adoption among Tokyo government staff, but also to expand engagement with Tokyo residents and international users. In addition, we will continue to drive effective use of the 3D viewer by expanding its application areas, conducting pilot projects, providing user education, and enhancing public outreach efforts. To promote the use of this platform and improve its usability, we are working to enhance the layer rendering speed. Specifically, we have implemented measures such as compressing 3D building model data and optimizing rendering parameters to reduce processing load and ensure smoother operation. While these efforts have yielded noticeable improvements, users with PC that have lower CPU performance may still experience slower rendering speeds. Feedback from these users indicates a growing need for further enhancements, so we will continue to pursue technical improvements to ensure that the viewer runs smoothly regardless of users' devices environment. We will continue striving to realize a digital twin that supports a better future for Tokyo and beyond. If you have any questions or comments or interests, please feel free to ask at Final Night Party or after this presentation. Thank you very much for your attention.